Hello everyone. I'm sorry I can't be there today. We are going to be finishing our notes on multiplying and dividing rational expressions that we started yesterday. If you do not have these notes because you were not here, please make sure that you pause the video and go get them from the box. Or if you are at home watching this, please print them out so you'll have a place to take notes. Okay, so yesterday we should have gotten through example 1, which is writing equivalent expressions, and we should have been able to simplify without any difficulty at all. And we should have also done the multiplying problems that are on the very next page through example 3. We are going to be starting today with the very top problem B as our warm-up. So what you want to do first is you want to go fraction by fraction, numerator by denominator, and you want to factor it as fully as you can so that you'll be able to cross out the right terms. So let's start up here at the top. X plus 3 has no GCF, greatest common factor, so you leave it as is. Now, this is not necessary, but if you want to break this apart so it looks more clear to you, please go ahead and break it apart. Now we're going to put our multiplication sign. Let's go up to this numerator. 3 and 18 have a 3 in common. Please factor that out. Then you go down to the bottom. 6 and 18 have a common factor of 6, so let's factor that out. Going over to our next piece, again, if you want to split these, you can, but you do not have to. And down here at the bottom, let's factor that piece out as well. So now you have this fully factored. As a reminder from yesterday, you are allowed to cross things out diagonally and up and down. You are not allowed to cross things out that are horizontal. So that means numerator to numerator, denominator to denominator. When you cross things out, please do not scratch them out like you're trying to eliminate them from ever existing, because we do still need to be able to see them. Okay, so first things first, I'm going to take out this x plus 3. Notice you can still read the words x plus 3 underneath. Please don't go bonkers and start crossing things out. You can cross out one of the two x's. Since they are identical, it does not matter which one. You cannot cross out these 4's. Those are both denominators. And you want to reduce this 3 with this 6, which would be a 1 and a 2. Okay, so now that we've done all our crossing out, we are going to multiply straight across. So this is gone, this is gone. We still have an x and an x minus 6. Down here on the bottom, that 4 is still there. So be careful when you're crossing stuff out to not make, not go crazy and cross it out, like so there's nothing there. So that's 4 times 2, that's 8. Times 4, that's 32. And then you still have the x plus 3. All right, so we have now simplified our problem. Now let's talk about our excluded values. So looking down here at the bottom, you have a term with an x right here that you crossed out. And we have an x plus 3, and we have another x plus 3. So you need to make sure that you are aware of what original problems would have caused the denominator to be equal to 0. So if I set this term equal to 0, I get 0. And since these are identical, it doesn't matter which one I set equal to 0, I get negative 3. So my answer is this, where x cannot be equal to 0 or negative 3. So this is my simplified fraction. Now, if you'd like to remultiply it, you can. That is up to you. You do not have to remultiply it. Okay, so there you go. Now let's slide on down to our multiplying example 4. So it says, what is the product of those two things? So let's set them up. By the way, I'm going to factor this as we go along here. So that would be x plus 2. And down here on the bottom, that's difference of squares of x squared plus 4 and x squared minus 4. Then you've got times, I can factor an x out of all of those. X squared plus 4x minus 12. And since it didn't have a denominator, you give it a 1. All right. Now let's talk a little bit more about our factoring. I can do a little bit more factoring right there. Now, if I factor that, that goes into imaginary, so I don't want to do that. That's considered one of those irreducible terms. So I don't want to factor anything like too far. I just want to do the basics with the factoring. Okay. All right, let me just pull that across over there and then times. Now inside here, I have another trinomial and I can factor it, so I want to. So factors of negative 12 that add up to be 6 are positive 6 and negative 2. And again, I do want to point out you do have a 1 in the denominator. Okay, now just a reminder, you can cross out anything diagonally or up and down. Binomials like x plus 2 and x minus 2 need to go with an identical binomial. You can't just cross out part of it. So I am able to cross out this term with this one. I am able to cross out the x minus 2 with the other x minus 2. And then I kind of have to stop. I can't go any farther than that. So when I write out my answer, I'm going to have x, that x, and I'll have x plus 6. If you would like to redistribute that, you certainly can. And then I will have the, and I don't really need the parentheses here. I just started writing them. I'm going to actually get rid of them. They look a little weird. Okay, so we got to here. We have our factoring done, but now we have to do the where business. Where x cannot be equal to, and we need to look back and we need to look at the terms that we crossed out in the denominator. So I'm talking about these two guys right here. If I were to set each of those equal to 0, I would get a positive 2 and a negative 2. Order is not important. I don't know why I put that little blurb there, but we don't need it. So the answer is, of course, this piece, but you also need this piece. Because even though you crossed them out, they still matter, because in the original problem, they would have caused me to have an issue. Okay, let's keep going on down here. So again, you may want to pause here and let yourself do a little bit of this factoring practice. If you want to, hit the pause button right now. And then I'm just going to keep talking. Okay, so that's a little bit harder. I need factors. I'm going to need a little more space. So I'm just going to kind of like slide down here and do that. So I would multiply 6 times negative 5. That's negative 30. And I need factors that add up to be negative 13. Okay, so don't pick the 3 and the 10, because you would have to make them both positive or both negative to make that work. And remember, we need a negative here, so one has to be negative and one has to be positive. So you have to pick the negative 15 and the positive 2. So that'll be 6x squared minus 15x plus 2x minus 5 with grouping, that's 3x and x minus 5. Nope, 2x and x minus 5. This pair don't have anything in common, so you put a 1. You should see a matching parenthesis. So all factored, this is 2x minus 5 and 3x plus 1. Okay, let me go put that back up here. 2x minus 5. Don't worry, my hand will be out of the way in just a moment. And 3x plus 1. If you need to pause, Please pause at any time. Okay, so this set, it looks like I can factor out an x that they all have. Okay, and then I'm going to need to factor that. Again, I'm just going to kind of go down here with the trinomial part. So that would be -10, and I need factors that have to be -3, so -5 and 2. So that would be 2x squared minus 5x plus 2 minus 5. First pair look like they have an x in common, leaving me with 2x minus 5. The second pair have nothing in common, so use a 1. So all factored, that's 2x minus 5 and x plus 1. By the way, if you're struggling with your factoring, please go and do some practice on Delta Math. It's very helpful. All right, so let's see what all we've got when we have it all factored. Remember, that's difference of squares, so go ahead and factor that out. Down here on the bottom, I've got that 2x minus 5 and the 3x plus 1. Up here at the top, I have the 2x minus 5 and the x plus 1 over 1. Okay, so here's the fun part, or at least it's for me, crossing out stuff. So I get to cross out this and this. That's 2x minus 5 with 2x minus 5. And yeah, that kind of looks like it. Okay, remultiply. And again, you can put these terms in any order. X times x is x squared, x minus 2, x plus 2. And then there's an x plus 1. Don't leave that off. And then you've got that over 3x plus 1. Okay, so there is my multiplication problem. Sadly, I didn't get to cross a lot out. Don't forget to add on your where x cannot be equal to, and you just need to set that equal to 0 and solve it. And then set this equal to 0 and solve it. And this makes up your complete final answer. Okay, we have one more down here at the bottom to give a shot to, and then we'll switch over to dividing. If you need to see it, great. If this is one where you've got the hang of it, you can move ahead. I'm just going to factor it out. So the top pair has a 3x in common, leaving me with x plus 2. Down here on the bottom, I've got a nice difference of squares. This pair, that is super nice. That's just x plus 7 and x plus 2. And remember, that's over 1 if it doesn't have its own denominator. Reminder, you can cross things out diagonally or numerator to denominator, but you can't do numerator to numerator. So I can cross this out, and that is only it, the x plus 7. So I'm left with 3x times x plus 2. Now, if you want to write that twice, you can, but just little, save yourself a little time with a square. And then x minus 7. Okay, so there's the result of my multiplication, but don't forget your where. So where x cannot be equal to, set this equal to 0, and you get 7. Set the term you crossed out equal, and you get -7. So technically, that's the second part of your answer. So we've now finished all the multiplication, okay? So that is all finished. Hopefully everybody did the notes on the other page yesterday. So let's try some division. Woo. So division. Here's the way division works. Quotient is going to tell you, they're also just going to put the little division symbol. You can see here's the word quotient, meaning divide. And then here's the division symbol. Here's what you got to remember to do. Change the sign to multiply and flip the second term. So we are going to take this big ginormous thing right here, which is x cubed plus 3x squared plus 3x plus 1. Yeah, we're going to factor that by grouping in just a moment. And we've got 1 minus x squared, difference of squares. And we're going to multiply by the reciprocal. And then this is just a multiplication problem. So let's break everything down and cross a bunch of stuff out. All right, so I need a little scratch space to do this. So I'm going to come down here away from the rest of my problem. So factoring by grouping, you look at the first pair, they have an x squared in common, leaving you with x plus 3. Your second, no. Did I copy down right? Yes, I did. Okay. Okay, so it doesn't factor by grouping. All right, so I got to take a different approach. Now, you may have noticed, I didn't when I first looked at it. I'm looking at it now and I'm like, oh my God, that's Pascal's triangle. So this is just x plus 1 to the third power. Now, how did I know that? Because when I tried to do factoring by grouping, it did not work. And so then I noticed it had a pattern of 1, 3, 3, 1, and we start with the highest power of x and we go down. So that is definitely a Pascal's triangle. So let's come over here. Let's write that out. Now, when you're doing this, you don't want to leave it like that with a 3. You want to expand that out. Okay. Now down here on the bottom, that is difference of squares, but the order on this is backwards. So this is just a little trick that I learned back in Algebra 1. If you want to flip those around, if you factor out a -1, it switches the order and the sign. So down here, this is going to be -1 times x minus 1, x plus 1. Okay, going over here. The next two are pretty straightforward. Factors of -4 that add up to be 3. That's just going to be +4 and -1. Okay, going down here to the bottom. Factors of 4 that add up to be 5. That's 4 and 1. Hey, did anybody catch that sign error I've got going on right up there? Yep, that's supposed to be a negative. Okay, cool. Glad some of you caught that. If you weren't paying attention there, remember I said it was +4 and -1, but I wrote a +1. So we got to fix that. Okay, so let's cross some stuff out. This one's very satisfying. I can cross those out. I can cross those out. I can cross this out. I can cross this out. I can cross out a ton of stuff. So that when I'm all finished, all I have left is -1 times x plus 1. Now, for y'all who are saying, but that -1's on the bottom, you know you can transfer a negative up to the numerator. Now, this one, though, has a lot of those where items, a lot of items that are undefined. Why? Because we crossed a whole bunch of stuff out. Let me write that a little clearer. Okay, so I crossed out this denominator. If I set that equal to 0, I get 1. I crossed out this denominator. I set that equal to 0, I get -1. I set that equal to 0, I get -4. And this one I set equal to 0 gives me -1. I already have that, so I don't have to add it on. So my final answer is that little beauty right there. Okay, we're going to do this a couple more times. So let's slide on down. Again, if you feel you're ready to do it, you do it. If you want me to walk you through it, that's what I'm here for. So factoring out this one, I get x plus 9. Now this is division, so you have to do times the reciprocal of the denominator. So I'm going to factor this. That'll be 3x and x minus 6. Okay. Here on the bottom, the order is a little weird on that, so I'm going to use my little factoring -1 trick to switch those. Okay, so let's cross out some stuff. I can cross this out with this. The 3 and the x are attached with multiplication, so I can cross out the x with the x and just leave the 3 behind. So let's put it all together. So I have 3 on the top, and I've got -1 times x plus 9. Okay, so choices. You can put the negative on the bottom and leave it there. It looks a little prettier if you shift it up to the top. That means exactly the same thing as this, okay? So you can put that negative in the top and the bottom, and then you're going to add the where. X cannot be equal to, okay, let's start over here. If I set the factor, this factor I crossed out equal to 0, I get 0. I set this factor equal to 0, I get -9. If I set -1 equal to 0, that does not help me because it doesn't tell me what x can be. So I set this factor equal to 0, and I get 6. So this is your final answer. Okay, let's try one more. And again, if you don't need this, you can skip over it. Most people need to see it, so I'm just going to walk through it. The top has a 2x in common, leaving me with x minus 6. Down here on the bottom, I've got x plus 5. Okay, change the division sign to multiplication and flip your second term. Okay, let's see what we get to cross out. You can cross this term out with this one and this one with this one. Please notice I'm not doing it so heavy that I can't actually figure out like what I crossed out. So that's 2x over 1, which is just 2x, where, okay, so x cannot be equal to, all right, x cannot be equal to -5. X cannot be equal to +6. So my total answer is this. Okay, so that is me simplifying rational expressions doing division. We have one final example to put our last little bit on here. Sorry I've had to talk so long. So let's talk about what's called a removable discontinuity. So that's a hole. So sometimes when we graph expressions, we expect there to be an asymptote. So using the rules that we've talked about, we would expect to see a vertical asymptote at +1. And if we have an equation that is top heavy, that would tell us that we had no horizontal asymptote. Now, when I go to put this into my calculator, this is what it looks like. Okay, so I want you to see what it looks like when I type it in. So I have parentheses x squared minus 1, close parentheses, nope, put the 1, close parentheses, divided by, open parentheses, x minus 1. All right, let's go take a look at the graph. What's going on here? I don't have that vertical asymptote that I expected. So I go in and look at my table. So if I go to my table, remember I expected that vertical asymptote at 1, there's an error message there. So what's going on with my graph? Why don't I see it? Well, let's take a look at the factors. So if I were to simplify this, I would have x minus 1, x plus 1, over x minus 1. So if you go to simplify this, you're naturally going to cross out those two factors, and you're just going to be left with x plus 1. Now, I'll remind you, this is y equals, see, f of x is y. So this means that y is equal to x plus 1. So that just looks like a straight line, which is what you see graphed here, which is what you see graphed here. But remember, when we do this, we always say where x cannot be equal to, when we set this equal to 0, 1, which is why we put a hole in our graph. you cannot see that hole no matter how much you zoom in. So if I change my window to a 5x5, I still won't see that hole because that hole is infinitely small. So we will talk more about this, but whenever you have a common factor in the numerator and denominator, it creates a hole, not an asymptote. So a lot of times you will see me say that the vertical asymptote or hole is, and here's how you find the hole. The only way you're going to do it is to factor the problem. So it says, how does the graph of f of x squared minus 1 over x minus 1 compare to this graph? Well, the graphs look the same with one exception. This one has a hole because we crossed a common factor, and this is just a plain old line. So the graphs are the same except where x equals 1. At x equals 1, the graph of g of x, which is the straight line, is continuous. It does not have a hole and passes through the point 1, 2. For the graph of f of x, it has a hole because the function is undefined. Now, when you write these holes, you make them nice and big on your graph paper so that you can see them. They are, in fact, infinitely small. All right, that is the end of our notes today. I will be back tomorrow, and we will be working on our review to help us get ready for our quiz that is coming up on Monday that will cover 4.1, 4.2, and 4.3. All right, so that's what we're anticipating. You can send me an email if you have some kind of questions or anything like that. I would love to help you out. Oh, and I do want to point out that there is a help session Thursday afternoon if you need it, just not by me. It would be by Miss Deich. That is just around the corner. So if you make a left and then you make a right, she is just down on the left side before the teacher bathrooms.